In this question, 2 points P and Q are a distance D apart. So let's draw that. P and Q are a distance D meters apart. That doesn't say meters, but we can assume that it is. And P moves towards Q, so in this direction, with initial velocity 2u. And Q is going to be moving in this direction with initial velocity 3u. Acceleration F for P, and retardation or deceleration minus F for Q. Well, we know that when they meet, regardless of where they meet, the distance traveled S1 plus S2 will be equal to D. So if they meet here, it's still going to be a distance of D traveled by both. Similarly over here. So we can probably start with that. Let's start with S1 plus S2 is equal to the distance traveled. And then we look at the questions. Maybe we're looking for prove that we're looking for time first. So the time in terms of D and U. So let's look at this S1 plus S2, UT plus a half AT squared for both. S1 is equal to 2U times T plus a half A, which is F times T, which is T squared. S2 is equal to initial velocity of 3U T, and it's going to be minus a half. You can see what's going to happen here, minus a half F T squared. And if we add S1 plus S2 together, we're just going to get 5UT. These will cancel, and that's equal to the distance D. And we were asked to show T is equal to something. So what is T equal to here? T is equal to D divided by 5U seconds. You can see that's what they're looking for. What are they looking for in part 2? They're saying prove that if the particles collide before the second particle comes to instantaneous rest, so that means that it must still be moving, so its velocity must be greater than 0 for part 2. So let's look at the velocity of Q, which is the second particle. The velocity of Q is equal to U plus AT. Its initial velocity is 3U. And its acceleration is minus F. And the time taken is D over 5U. And we're saying that this is going to have to be greater than 0. So what have we got here? We have 3U would have to be greater than FD over 5U. And if we cross multiply, we're going to get 15U squared would have to be greater than FD. And they want it the other way around, so we reverse the inequality. If 15U squared is greater than FD, FD is less than 15U squared for part 2. In part 3, if FD is greater than 30U squared, then the second particle has returned to Q. Well, if it has returned to Q, it starts here, it goes in this direction, and then comes back to this exact point. We can say distance traveled will be 0. So let's take the distance traveled for S2. It's this one here. So we can say 3UT minus a half FT squared will have to be equal to 0. Like they're looking for it as an inequality, so it could be less than or equal to 0. So we'll change that at the end, maybe, or now, less than or equal to 0. So it's going to give us, we know time, so 3U times D over 5U minus a half F, and if we square this guy, we're going to get D squared over 25U squared. D squared over 25U squared will have to be less than or equal to 0. because I suppose we could say that the distance on this side would be negative. We get a negative answer. So the u's will cancel here. We've got 3d over 5 less than or equal to, I know I could have cancelled the d, we're going to have fd squared over 50u squared. So we divide by d and multiply by 50u squared, we'll get 150u squared less than or equal to 5fd, and dividing by 5 we get 30u squared will be less than or equal to fd. Fd will be greater than 30u squared. Yeah, well, that will work around. We turn it around. Fd will be greater than 30u squared. That's part 3. And then the dimensional analysis, Fd is equal to 30u squared. So acceleration is meters per second squared, or s to the minus 2 m over s squared, or ms to the minus 2. Distance traveled is meters, so times meters equals 30 times initial velocity is ms to the minus 1, or meters over seconds. So we have m over s times m over s. So we have meters squared over second squared equals meters squared over second squared. We don't need to worry about the 30. So that's the dimensional analysis aspect of this question.